Good evening, everyone, and welcome to Sky Observer's Hangout. We're so glad to have you here today. My name is Michelle, and I'm coming to you from the Adler Planetarium in Chicago, and I have a friend joining me here today. Hello.
Yes, I am Hunter, public observing educator here at the Adler Planetarium, and we're so excited for this episode of Sky Observer's Hangout today. We've got lots of fun stuff planned. As you can tell from our title today, we will be doing some Jupiter observation, but lots of other fun stuff planned. Yeah. Special guest that we were able to interview a couple of weeks ago who will be coming to the show today. So lots of exciting stuff. Now, it's not just the two of us here on the team. We've got lots more help too. Right next to us here, our producer Dylan for the evening, also a public observing educator here at the Adler.
Yep.
We also have a couple folks helping us online. If you see the Adler Planetarium's name next to it in the chat, that is Jennifer. She'll be our chat moderator for this evening. So if you have any questions or anything that you want to let us know, you can post those things in the chat and she will pass those along to us tonight. So make sure if you have questions along the way to share those with us. And we also have our astronomer friend Geza here today, who will be helping us answer those extra hard-hitting questions. You know, I always say he's there for the numbers. Those are always tough. So we appreciate Geza being around to help with some of those big ones.
For sure. Well, if this is your first time here, hey, welcome. Sky Observer's Hangout is your place, our place, to gather together to just nerd out about the sky. Anything about sky observing. If you just want to sit back and watch, that is totally okay. Please do that. If you would like to interact with us, we would love that. There is the chat right there that you're watching. Scroll by. And please put your questions and comments into the chat. Share information with each other. Tell each other about how you're observing the sky right now. Hopefully it's not too cold where you are. It's a
little chilly here tonight. So we're doing it from the shores of Lake Michigan here in Chicago, Illinois. I don't know. You might be able to see our breath on the camera. I'm not sure. We've got our electric hand warmers, lots of gloves and hats here tonight. Apologies for any sniffles you might hear. But we're so excited to be here providing the telescope views that we're able to offer here tonight.
And definitely let us know, where are you tuning in from? So please put that in the chat and Jennifer is going to pass that information along to us. And while you do that, give me just a second because Hunter's going to talk to you. I need to adjust the telescope because lo and behold, it's amazing. It's December in Chicago and it is clear.
There is at least some level of clarity, though I'm not sure why it's so dim right now.
Yeah.
Maybe a little cloud getting in the way. We'll see.
Anyway,
but we've already gotten some views through the telescope tonight. We're really excited about it. Now, if you enjoyed the show tonight, if you are a lover of astronomy content, whether you're from Chicago or from a little further away, you should hit subscribe down below. That'll let you know when we're doing future episodes of Sky Observer's Hangout, but it will also give you all the other wonderful content that is on our channel. So definitely make sure to subscribe if you're enjoying the content tonight.
I need to move the roof.
Move the roof a little bit? Okay, apologies for any loud noise. You might see the roof spinning behind me here, the big red part in the background here.
Ready? 3,
yeah, go ahead.
2, 1.
Okay. So right here behind me is our Planewave CDK-24 telescope. Now this telescope is fully electronic. It is tracking the objects that we're observing as we look at things in the night sky. Roof's a little older, we have to adjust that as we go. So that's why you can see the whole building spinning behind us. Well, we always love to start straight off with our telescope views, right?
Yes.
And especially with something like Jupiter tonight, it is a great thing to start with. So
that looks pretty darn good, doesn't it?
that is not bad for a little winter observing. We've had lots of cloudy days recently. We haven't been able to do any of the stuff we've been trying to do out in the observatory. So I'm really glad that we were able to share these views with you tonight. I also see some folks join in from, we're seeing that folks are coming from Chesterfield, Massachusetts.
Hello, Chesterfield. I don't think we've had anybody from Chesterfield before.
That's true.
That
Chesterfield doesn't ring a bell. I bet we've had a Massachusetts before.
Oh,
but
for sure.
Maybe not Chesterfield. And then folks viewing from across Illinois tonight. So that is very exciting. So if you're in the Chicago area, come visit us.
Keep telling us where you're coming in from. We'll break in and mention that. But this is a live view from our telescope. So this telescope right here, and what you can see actually directly behind Hunter's head. So if Hunter could back up for just a second.
There
so this blue thing looks right up there. That is the camera. It's just at the top of your view. And so that is what's taking the live images right now. And I just need to adjust the exposure just a little bit.
one thing that's good to know with astronomy imaging is that your conditions are a really big part of it. And so tonight we've had some, kind of a wavery image. It might be a little jumpy, you'll notice. There will be some frames where it's very clear, others where it is much more blurry. It just comes down to the conditions, and we upped the exposure time to allow it to be brighter when what I think was a cloud got in the way for a minute there,
It was
right? Or was it literally the roof?
We're partly looking at the sky, partly looking at the roof. But yeah, I have to keep adjusting the exposure time a bit, but that's okay. That's what we do.
Now, outside of, what will be a topic later on in the show talking about the Europa Clipper mission that NASA currently has traveling to the Jupiter system, there's another reason why tonight is a great time to be observing Jupiter. What's special about Jupiter right now, Michelle?
It is Jupiter opposition. So what that means is, as the sun goes down, Jupiter comes up. So Jupiter is opposite the sun in the sky. So you could draw a line, kind of, between the sun, the Earth, and Jupiter. And so that is going to happen on December 7th. But we're really close enough. We're taking advantage of the fact that it is actually clear out tonight.
Exactly.
And someone asked if it's as cold on Jupiter as it is in Chicago.
That's a more complicated question than you might expect.
I would say we'll talk a little bit about what you're actually seeing when we look at Jupiter, but we'll suffice it to say the cloud tops of Jupiter are colder
very chilly,
than
very
Chicago.
chilly. Yeah, absolutely.
So it may be hard to believe, but yeah, it is definitely going to be colder there.
Now, when we have something like Jupiter in opposition, right? When we're looking through a telescope like this, because we are closer to it, it can appear a little bit larger. If we saw it when it was opposite the sun, right, it would take up less of the field of view of our image.
Yep.
Now, one thing we always like to talk about is how folks can observe these objects at home as well, right?
Yep.
Now, planets don't appear as, these big, large disks in the sky like they do through a telescope, so it won't appear larger, but there are some benefits to viewing Jupiter at opposition, even outside with the naked eye, right?
Yep.
And that is that it will be much, much brighter. It'll really, really stand out well in the sky. So what we have up here on screen now is a view through a program called Stellarium. And this is a wonderful program that's like a really good observing tool, night sky map. This is for, I think I set it for 7:15 tonight is when I was taking this snapshot from here in Chicago. And starts to give you an idea of where you can find this object in the sky. So do you have any tips for folks trying to observe Jupiter tonight with their eyes?
Absolutely, yep. If it is clear out where you are, so clear and dark, it needs to be dark out. If you are anywhere in the Eastern time zone, Central time zone, Mountain time zone, probably getting dark in the Pacific time zone, you need to go outside, face east, and look up. It'll be the brightest thing that's in your sky. One of the things, please note on the Stellarium website snapshot is notice the size of the dot for Jupiter. That does not indicate size in the sky. That indicates brightness.
Brightness, exactly.
So the brighter the object, the bigger the dot that you'll see on the screen. You won't actually see a disk in the sky. You will see a bright object in the sky.
Though I will say, with how bright it is right now, it really does stand out. Much brighter than any of the stars surrounding it. It really stands out, and every time I talk to people about observing planets in the night sky, they're often a little surprised. They say, "That's Saturn right there," or "That's Jupiter." It can be a little shocking to hear. They're really there, quite frequently. We get to observe these planets lots of the year, but it makes it extra special when you're looking at it and you know what you're seeing, right? And so it's a great time to, I know it's cold, so just a quick peek outside to the east. I'm sure you could see it through a window if you have eastern-facing windows as well.
Will. Absolutely.
It's still fairly low in the sky for now, but getting higher and higher throughout the night, moving into the southern part of the sky.
Yep.
Since it's in opposition, it's opposite the sun in the sky, so it'll be reaching its highest point around midnight.
Let me check and see the altitude of how high it is in the sky right now.
Yeah, I think it's around 25 degrees right now-ish.
Let's check. Hang on.
You see me messing with my hand warmers. It is definitely chilly out here.
Yeah, so 26 degrees up in where we are in the central time zone. So if you are in the eastern time zone, it's going to be a little higher in the sky. If you're in the mountain time zone, it's going to be a little bit lower than it is in the Chicago area. Oh, hello, Karen from Kenosha. We know who Karen is in Kenosha. She's a regular viewer of Sky Observers Hangout and one of our colleagues at the Adler. And someone...
There's also someone joining from South Bend, Indiana. Special shout out to you, my home state, Indiana in the house, as Jennifer said. So thanks for coming and watching. All of you folks, Kenosha, South Bend, you'll have a great view of Jupiter right now. It gets nice and dark early.
Yep.
And with these really quite frigid temperatures we've had recently, it can be kind of a benefit for observing sometimes. It can result in a pretty clear sky. Things can really stand out, I feel like.
Yep.
And so great time to go out and catch Jupiter right now.
Exactly. Want to go back to that telescope view?
Yeah, let's get back to our telescope view and talk a little bit about what we are actually seeing, because while observing it with the naked eye is great, we do get a lot more detail through the telescope, right? And so, I mean, I think the first thing that really stands out to me, and this is the case through the big telescope, but also through, you know, a lot of small telescopes that folks might have at home as well, is there's two dark bands across there that we see, those lines perfectly parallel across there. What are we seeing with those?
So you're seeing the cloud tops of Jupiter, and the dark bands are areas that are a little bit warmer, a little bit lower altitude. The lighter areas are a little bit higher altitude, a little bit colder, well, a lot colder. And so you're seeing different cloud belts and zones in Jupiter's cloud tops, and so it's a really interesting view to see because Earth doesn't look like this.
Right, I think it's a really important distinction to make when we talk about a planet like Jupiter, is that, you know, I think our first thought when we think of a planet is very Earth-like, right? Of course, we live here, is what we're most familiar with. We think of that rocky crust on the outside. When you're looking at something like Jupiter, you're not seeing any kind of a rocky crust, right?
Nope.
This is a gas giant for a reason, right? That's a name that we hear often. And so this outer layer that we're seeing is really just atmosphere, right? It's really just clouds.
Exactly.
And it's much different on the inside than an Earth planet is as well, right?
So we have someone who is watching us from Southern California, where we're pretty sure you don't need the hand warmers now.
They're probably quite lucky right now.
Southern California is the home of the Jet Propulsion Laboratory.
That's true.
And the Jet Propulsion Laboratory, I believe, is the home of the Juno spacecraft.
Mm-hmm.
And the Juno spacecraft has told us an awful lot about Jupiter itself, especially its interior.
Mm-hmm.
And so when you're looking at the outside of Jupiter, you're looking at the cloud tops. And then actually, we use that phrase gas giant. The gas part is only like a thin layer on the outside. The rest of it, if you go farther in, it's a liquidy layer. And when you go even farther in than that, that liquidy layer starts to transition to kind of a solid layer. It's not a solid, or it's not a sharp transition from one layer to the next. It's kind of a gradual transition to something on the inside what's more like a mixture of this strange stuff called metallic hydrogen. Basically, hydrogen is squished so much it starts to act like a metal. It can conduct electricity. And then silicates, rock, and stuff on the inside. We don't totally understand this center part because we just don't have that here.
It's tough, right? We don't have it here. It's really far away. We've got all of this gas to get through, all of these different states of hydrogen to get through before we can even make it to that central portion of it. And so this is ongoing astronomy.
That and trying to recreate those conditions on Earth to test it out in the lab and see what these things are like.
Right, those high pressures that are on the interiors of a planet.
Yep.
So, we were talking about how it's probably quite cold on Jupiter. Probably not in there.
No, the interior.
Gets hot pretty fast. Gets hot pretty fast as you go down.
Geza can probably look up the temperature of what we think the center of Jupiter is. I want to say, for some reason, the number like 10,000 degrees is coming to mind. I may be greatly exaggerating that. I apologize.
The hand warmers might help to cool off
yes,
at that point.
Yes, it's a little bit warm. But now we're back to our live view of the planet Jupiter. And we got a couple little companions there. I'm actually really pleased with how the view looks. We played with the focus of the telescope for about an hour.
It's a little tricky on a day like today when it is, when it is kind of jumpy. It's getting a little more still now, though.
Yeah.
In our setup, it was definitely a little jumpier, but it's starting to get more steady and good, consistent conditions. So that's good to see.
Yep.
Now, we've talked a little bit about, these belts that we're seeing, right, and this beginning view through the telescope, and it's the figuring out what these outer layers of the planet were wasn't something that was immediately obvious when we look at this, right? We can imagine that an image like that with just these striped lines across it could be something similar to us, right? But then, as we have traveled to it and gotten closer to the planet, that has really started to reveal a lot more about what is going on there. And I love this time lapse this is from Voyager 1. So these pictures were taken over the span of a month in 1979 as it was traveling past it, which still continues to travel on in the outer reaches of the solar system.
Yep.
But I love that in this video, you really see how dynamic a gas giant is, and it really starts to give you a better idea that these are the clouds up top that are constantly moving around. And you mentioned something really interesting earlier about why these sorts of clouds and storm systems end up appearing in these belt-like structures rather than what we might expect.
Jupiter spins so quickly. It spins the fastest out of any planets in our entire solar system. It is the largest planet in our solar system, so think about that. If you have a hollow Jupiter and you fill it with Earth marbles, you would fill it with about 850, 900 Earth marbles, something like that. And then just think to yourself how big that planet actually is, and it spins in less than half the time that the Earth does. So less than 10 hours for that big planet to spin once. And so that means it's going to stretch out those storms, which we're used to storms being more circular. The storms in Jupiter's atmosphere are going to be stretched out into these bands and belts and zones. So yes, someone asked, that photo is from the 70s? Yes, these are a series of images from the Voyager 1 spacecraft as it was approaching Jupiter during its encounter in 1979. It's really amazing to think. You think, wow, you're not used to photos being that good.
I know, and then we were able to start getting this detailed imagery from so far out so early. But you have to remember, in the 70s when this was happening, these were really, really groundbreaking images. Sorry, you might notice us peering off to the right sometimes, or maybe that's the left for you.
We have a screen.
We can see the image of Jupiter over here, and just as enchanting as the first time I've seen it. Now, one thing we talked about that we, is really noticing these belts in the images that we had through the telescope. But one thing that I notice here that we didn't see in our view that is, a very well-known feature of Jupiter is that great red spot there, right?
Yep.
And this was something that we weren't catching in our live telescope view earlier, right? And when we get a more detailed view of just the great red spot itself, we can see that it starts to remind us maybe a little bit more of some of those storms here on Earth. But because of that rotation, you can't see it all the time. Almost every picture you see of Jupiter has that spot facing right at us. But that's not always the case. They do that on purpose. It's very eye-catching.
Exactly.
It's very eye-catching, right?
Yes.
But we can look forward to it beginning to come back around at 7:15. We'll see if we can catch it later into the show. It'll be tough to spot along the edge. We might be able to see it a little bit later. We'll see.
Yeah,
It's
we'll
not
see.
the best conditions tonight. As we mentioned with the kind of jumpy image and the troublesome focus. But in this picture, I love seeing the swirling patterns within the Great Red Spot. It really starts to invoke, right, some of the weather patterns that we see here on Earth and that are at an even greater extreme there on Jupiter.
What's fascinating about the Great Red Spot to me is people call it a cyclone. It's actually an anti-cyclone. It's a storm that it's not a storm. It's a high pressure system. But we think of hurricanes looking like these round circular things, and it's a round looking circular thing, so I think it's okay if we call it a storm. A lot of people do. But one other thing is you might notice the bright colors in this particular picture, but if we switch back to the telescope view, you don't see those really bright, vibrant colors. This is more of a true color picture. We've got the color camera on the telescope tonight, but this is more of a true color picture. A lot of the pictures that you might see, the colors are real, but they're enhanced. So they're a little bit more vibrant in the picture when it's released to the public. And that's just because it helps your eye, your brain, pick out different patterns and things that you might not be able to see otherwise.
Right, it makes the distinction between different regions more striking. And when you say true color, what we really mean is how it kind of looks to the eye when looking at it as well,
yes.
right?
Yeah, if you were to go there and look at it, and so how the human eye would perceive it, how you might see it if you were to come, say, on a clear Wednesday night to the Adler Planetarium.
Exactly.
When the winds are not as high as they're expected to be this Wednesday.
It does sound like we're going to be closed this week, so don't come this Wednesday, but look forward for future Wednesdays.
Exactly. Future Wednesdays, if they're clear, then we would point the telescope at Jupiter or Saturn or whatever happens to be in the sky. So this, you would be able to see it look very, very similar to this, kind of a pale tan color.
Right.
Yeah.
Now, that's not something that we can often say when we're doing Sky Observers Hangout. A lot of times we're looking at deep sky objects, galaxies, globular clusters, all of these nebulae, and those objects with the camera really look a lot better than they do to the eye, I think. You know, through the eyes, they're very dim. There's not a ton that you can see. You can train yourself to see them better, but they are tough to spot. With planets, I would almost even argue that an eyepiece view is even more beautiful sometimes than the live camera view. You know.
Yep. And one thing that your eye would be able to do way better than this camera can is take a nice sharp. You're going to get a sharper view, and that's because the exposure that you're seeing right now is a time-lapse exposure. So we have to keep the shutter open on the camera essentially for a certain period of time. And during that time, it's kind of jumping around, it's a little jiggly, it's a little tiny bit smeared from what you would see with your eye, because for this image, I think the camera exposure time it's a fraction of a second, while your eye would be even shorter fraction of a second for refreshing. So your eye would be able to see Jupiter actually more clearly than this camera can.
No. Another thing that I think your eye can do a little bit better than cameras can when it comes to planetary observing is, right now we've got a great view of Jupiter, but I can make it out here in person. I don't know how great that looks over YouTube with some of the quality changes that happen during streaming. But I also notice a couple of other objects in view here. Do you think we would maybe up the exposure a little bit to bring them out a little more? So when you look with your eyes, our eyes are really good at adapting, to not only seeing Jupiter really clearly at its light level, but also some of these surrounding dimmer objects. And so you'll notice that as we adjust the exposure here, a couple of other dots come into view quite strongly now, right? They're very obvious. And so, what do we see in there? Are those just background stars, Michelle?
Oh no, those are moons. So those are two of Jupiter's largest moons. We've got Europa and...
I believe it was Europa and Ganymede, but we'll get back to that here soon and check.
And I will move the telescope because we can't get all three that are visible right now in the same view. But let me move it.
Might be the other stick, I think.
Oops. Oops, wrong way.
Wrong way. Just to prove that this is a live view always. The only reason we ever don't show a live view is because it's cloudy out. Ah, there's the last one over there on the side. So we're spotting a couple of these moons tonight. Now, one thing that I want to point out is that these are not all the moons that Jupiter has. So it's very different from Earth, right? We've just got our one big moon here. Good finesse with the analog stick there, Michelle. It is tricky for anybody that hasn't tried that before. It is hard.
If you're wondering how we control the telescope, it is an off-the-shelf game controller.
Yep, just a Bluetooth video game controller. And so, while these four moons are the only ones that you can really realistically spot with a telescope, some very large telescopes can spot some other ones, but these hold a really huge percentage of the mass of Jupiter's moons. There are a total of at least 95 now, so that number is constantly rising. Each year we add a couple more to the database, right? Or every few years as another sample gets done of it, right?
Keep finding more.
A bigger telescope gets pointed there that can spot even dimmer things or something, and so that number is constantly rising. It's up to over 95 now, but these four are, you can see them in any kind of modest telescope, probably even any set of binoculars that you might have. They're pretty easy to spot, and so it's very exciting that we can see some of those things. Now, we talked about using Stellarium for finding where Jupiter is in the night sky, but another thing that it can be really useful for is locating those particular moons. So this was from the exact same time as I took earlier at 7:15, and I just zoomed in on Jupiter, took a closer look. Now, I took these images with Chicago in mind. That won't adjust your positions of the moons, but it will adjust your position of Jupiter in the sky. But it will adjust to your location, the time that you're looking at it. It's a great tool. And in here, we can actually spot which moons are which. And, that's important because they're not always in the same spots, right? They're orbiting around Jupiter. It's in a time span that, each day that you look, they'll be in totally new positions. And so even if you are, the biggest Jovian expert in the world, I think you'd still have probably quite a bit of trouble trying to identify the moons just off that snapshot. So we've got a few of them here in this nav. Now, one thing you'll notice is that we've only got 3 of these moons there, and we were mentioning 4 that are visible. So what's going on? I mean, you moved the field of view to point the other ones out. Where's the 4th one hiding?
Hiding behind Jupiter. So hopefully by the, let's see, what about 15?
Let's see, I think 7:40. Yep. So in 15 minutes, Io, the 4th one that we haven't spotted yet, should be making its way, peeking out from behind Jupiter. So it is lined up just right with us right now where we can't see it, but hopefully we'll be able to spot it as it comes back around later in the night.
And if you have a small telescope, you can see these moons as well.
Yeah, no problem.
You'll see Jupiter as a small disk. You'll see a couple little bands, the dark belts, and then you'll see up to 4 moons.
And there'll be one thing that's also really helpful is that they'll be very nicely lined up around Jupiter, right? So you'll see them in that nice line. Sometimes you can get tricked by background star a little bit, but those will often be, in slightly off positions from where those moons would typically find themselves.
Yep.
So
these guys are all lined up with Jupiter's equator. So when you see it kind of angled like that, that's why the moons are angled. It's all lined up with Jupiter's equator in the middle.
Now, we've talked about those 4 Galilean moons tonight, but really one of them is going to be our main focus for this evening, and that is Europa. Why is Europa so special to not just us here at the show, but really everybody right in the astronomy community right now?
There's a spacecraft headed there right now, and so it is called Europa Clipper, and it launched in October, and it is on its way. It's got a 5.5-year journey to be able to get to Jupiter. It's going to make a flyby of, I believe, Mars and Earth at some point. So if you launch something to go straight out to a planet, you need a lot more rocket fuel. You need to get that thing going a lot faster. It's a lot more expensive. So you get there faster, but it costs a lot more to be able to do that. If you take a much more roundabout way and go past, get a little extra gravity boost from a couple planets, then you don't have to use as much rocket fuel to be able to get there. But it takes longer, so there's a trade-off.
Yep. But while it travels there, there's still, lots to learn. And this next segment will really help us with starting on that journey. So we were lucky enough to get to interview with Cynthia Phillips, planetary geologist that worked on the Europa Clipper mission with the same Jet Propulsion laboratory that was mentioned earlier, talking about the Juno spacecraft. And so we will send it away to our first segment of that interview here. Welcome, everyone. We are so excited for this really special segment of Sky Observer's Hangout today. When you join us, we love observing the sky, but we also like talking about how we know the things that we know. And so today we wanted to interview a very special guest that will really help guide us in learning about how we know so much about Jupiter and its surrounding bodies today. So today we are joined by Cynthia Phillips, a planetary geologist at NASA's Jet Propulsion Laboratory and an essential piece of the Europa Clipper puzzle. Cynthia, do you want to introduce yourself?
Thanks so much, and I'm so excited to be here today. Yeah, so I'm a planetary geologist at JPL. On the Europa Clipper mission, I'm a project staff scientist, which means that I work for the project science team basically, and I'm also the project science communications lead, which means that I get to coordinate with our public engagement and media partners to really think about sort of sharing the story of Europa with the broadest audience possible.
Well, that is an awesome introduction to our first question for you, which is, you're having an elevator conversation with someone about Europa Clipper, and right before those elevator doors open, you got to have this conversation done. How would you describe Europa Clipper to your elevator companion?
Well, so usually I have to just start with, what is a Europa, right? For people who, like me, who are, I've been obsessed with Europa for 25 years now, but I will admit that not everyone shares my obsession yet. I'm working on it. And so usually I would start by saying that, Europa, it's a moon of Jupiter. It's about the same size as Earth's moon, but we think the surface is covered with ice, but below that ice, there's an ocean of liquid water that is more water than all of Earth's oceans combined. And that ocean is there today, now, in the outer solar system. And so Europa Clipper is a mission to go and explore Europa to tell us whether that ocean could be habitable. Could there be places below Europa's icy surface that could support life? And usually by then the elevator doors have dinged and either they've run away from me or, or we like stay in the elevator and block the people who are trying to come in and out because they want to hear more. So, it can go either way.
I find just the tidbit that more water than Earth's oceans.
Yes.
Yes, there really are places in the solar system that have more water than here. It is a fascinating thing to consider. So that already would have me intrigued. I'd stick around in your elevator to hear more about it. So, Hunter?
Yeah, I love that comparison, getting that relationship to the water that we have here on Earth. That's something that we can try to imagine. It feels like an unimaginable amount, and to know that that much is out there somewhere else that we haven't visited before. So exciting. Now, you started to introduce us to your role with the mission a little bit. Could you expand on that a little bit and tell us a little more about like your kind of role with Europa Clipper and what kinds of things you go out and do to help support the mission?
Yeah, so I've I wear a lot of different hats on Europa Clipper, as many of us do. And so kind of my primary role as a project staff scientist is I do whatever the project scientist tells me needs to be done, right? So Bob Papalardo is the project scientist, and so he's basically kind of the science lead for the whole mission. And then we have principal investigators who are the leads for each of our instruments. We have about 10, depending on how you count them, different science instruments on the mission. Each of those has a principal investigator, and then they have a science team. And so what we do on the project science team is basically we coordinate all of that. And so that goes to, all of the behind the scenes stuff that make the science team work, is kind of what I help with. I also am the co-chair of the reconnaissance focus group for Europa Clipper. And so on Clipper, we kind of have our payload and our science is sort of divided into a couple of high-level working groups, and those are science topics like geology and interior and composition. And then there's some focus groups that are a little bit more focused, I guess one could say. And so the one that I work on is the reconnaissance focus group. And so the idea of this focus group is basically that the Europa Clipper, it's going to orbit Jupiter with multiple close flybys of Europa, about 50 or so flybys. It's not going to land on the surface. It's not going to touch Europa. But we're thinking about a future mission. If Europa Clipper is as wildly successful as we all think it's going to be, if it finds those places that could be habitable, those places below Europa's surface that could support life as we know it, I think that, everyone hopefully is going to say, okay, where's my lander? Where's my follow-up mission to tell us, let's touch the surface. Let's actually land on Europa and see whether those habitable places are actually inhabited, right? Is there life there today? We all think that probably a life detection mission, it's going to take actually touching the surface. It's possible that maybe we'll get really lucky and we'll find some signs of life in the material that's thrown off the surface into space as we fly by. We collect that. We do some, compositional analysis. So maybe we'll find something, but most likely we're going to find kind of some intriguing hints, but we're going to have to go and land. And so this reconnaissance focus group basically looks at the places that we're going to see Europa. We're going to have about 50 close flybys with the Europa Clipper mission. And on each of those flybys, we go over kind of a little bit of the surface. And we'll get to have, nice kind of regional scale imaging of over 90% of the moon. But to get that really high resolution close-up data that you need to guide a future lander down to the surface, and also to select the most scientifically compelling landing site, it's really going to be this very small chunk of real estate kind of under each of those close flybys. And not every flyby actually gives us the right information that we need. And so of those 50 or so flybys, there's maybe a dozen that actually meet all of our parameters for a future landing site. And so what this reconnaissance focus group does is it looks at each of those dozen or so potential landing sites in as much detail as we're able to. And so the idea is that once we actually get to Europa and collect that data set, we want to make sure that we're doing the best job we can on those kind of special flybys to collect the best data set for a future mission that we can.
I find it fascinating. Before this spacecraft even got off the ground, you were already thinking about the future beyond this craft, because it's not even going to get to the Jupiter system for several more years. So that is fascinating to me. So you're thinking, hey, we've got this great opportunity to get this world-class data that we can use in the future. So let's put our future hats on and what future us might want to do to develop that kind of a mission. That's
Absolutely.
That's amazing. Yeah, I bet that's an aspect of spacecraft development, design, and facilitation of a mission that people probably don't even realize happens. So yeah.
And I think something that really reveals for me too is, right, that's just a piece of the Europa Clipper puzzle. Listen to all of those details, all of this big future thinking that's happening. And there's many different teams piecing together to get this one spacecraft out there and getting as much science done as possible. So it's so many moving pieces. And what you're able to get with that is remarkable.
Welcome back.
Yeah, welcome back.
Welcome back. And Rick from Virginia, we're glad you made it to Cynthia's interview. That's awesome.
yes.
So welcome back, everybody.
I think one thing that is so interesting to hear from me when talking with Cynthia is the amount of detail that she speaks on, even just her little part of the Europa Clipper, right? There's so many different tools and pieces that make the spacecraft itself, right? And to hear all of the thought and planning that she has done and her team has done just for that recon mission, right? Just to image that surface, try and see where we can send something for the future, right? All of that thinking in the past and all of that work to mostly be a project that's really thinking about the future was something that was very eye-opening for me, and I think something you don't often think about. From an outsider's perspective, when all we have to do is look at the pretty pictures that they send us back and learn all of the cool new things that they discover. Right?
Yeah, just like the Perseverance rover is putting rock samples on Mars for a future hasn't even been put on paper yet mission to go pick up, or thinking about where a future has yet to even be thought of mission to land on Europa. That they're thinking that far ahead, literally decades ahead, was really cool to hear.
And as we talk with Cynthia, I think it really started to also reveal to me, how important these missions are, how much there is to really discover there. And I think that was something interesting that we could talk about next, was the kind of importance of observations of Jupiter's moons and how much they have meant throughout history, right? So to start off, we'll talk about these 4 moons, the Galilean moons, right? We mentioned the name earlier. We might not have gone into too much detail here. So we call them the Galilean moons. The 4 images that you see here right now of these different planets, Io, Europa, Ganymede, Callisto, these were taken by the Galileo spacecraft, right? And this starts to tell us of, really why these objects are important and why observation of these objects is important. So what's up with all the Galileo names, Michelle? So
you may wonder, Galileo spacecraft, Galilean moons, they're named for Galileo. I know you've heard of this guy, but what exactly did he do? So among other things, well, first thing, he did not invent the telescope. It's a common misconception. What he did was he made a version of the telescope a little better, and he was able to point it up at the sky. Shall I show everybody this?
I think that's a great idea,
This is not a
Here, maybe
real...
I can scoot back a little bit and hold it while you talk to the good people.
This is a replica of Galileo's telescope. This is a usable replica. We got this built by a wonderful couple, the Morrises, who live out east, and they specialize in creating replicas of scientific instruments, Jim and Rhoda Morris. And so I thank them all the time for this. And so this is a working replica of Galileo's telescope.
Now this is just the telescope itself. We also have a mount that goes along with it that is meant to reproduce that, but it's kind of big and clunky, so we just brought out the scope to demonstrate this today. And this is what the first observations of these Galilean moons we're looking at, right? So we can't spot it with the naked eye. And yeah, I mean, Michelle's pointing out a very important part of this.
Yeah.
That's the lens.
That's the part, that's not the part you look through. That's the part you point at Jupiter.
That's the part that's seeing everything, right? And so now we've got a 24-inch wide mirror in the back of this thing, providing us much more detailed views of Jupiter and well, I mean, especially Jupiter, but also being able to spot those moons a little easier, right? I mean, I have experience looking through this thing. You know, usually we get it out to show people just how hard it was to look through, right?
It is remarkably difficult to look through this thing, but that's the point.
Exactly. He was able to make so many discoveries with, I mean, look at it. It almost looks like the tube of a very, very large paper towel roll.
Yeah, exactly. and the lens that you look through there's a small lens at this end. This will magnify about 20 times. And so the fact that it works at all is...
To bring it in focus, you just slide this back and forth. This is a removable tube that fits into the back there.
Yep, and his original telescope was covered in paper, and so...
Yep, much like this one is.
Yep.
Dating all the way back to 1610.
1610.
1609 even.
Yep, and so what he did was, among other things, he pointed his telescope at Jupiter, and what he saw was recorded in a book that he wrote, so if we can...
Right, so he's got this book, Sidereus Nuncius, that he publishes, which is a really, really revolutionary, piece of astronomical research, right? It was his first publishings after he had started to use his telescopes, observing the sky, and here we can see him documenting movement of these moons around Jupiter, right? So we mentioned we'd be able to see Io peeking out later and that they're constantly moving as you look at them over different days. And so he was doing this over the span of a few months, right? Noticing these dots changing position over time. First time he observed, much like we had today, he only saw 3 of these moons, right? And over time, he started to realize there were 4, and this is him documenting that process, drawing the O's that you see are Jupiter itself with the little asterisks, the little stars indicating the positions that he was seeing those moons in over time.
Yep, so over the course of many days, he recorded this, and he recorded that these objects moved, and they appeared to orbit Jupiter, which was amazing, astounding, because at that time, everybody just assumed everything orbited the Earth. That's what it looked like. And so he had some proof that there were these objects that did not orbit the Earth. And so this was an incredible discovery made with an insanely difficult to use telescope that was not on a motorized mount or anything like that.
A paper tube with a couple glass lenses on either end that he handmade.
By the way, Lillian is asking a wonderful question. She wants to know if Galileo's actual telescope exists or if it has been lost to time. It exists.
I was gonna say, I believe the very first one does still exist, right? Because that is what they modeled this telescope off of.
Yes.
They went to, it's in Florence, is that the right city in Italy?
Yes, so Lillian, book your trip to Florence, Italy, and then go to the museum there that has Galileo's telescope.
It's like a Galileo museum, if I remember correctly, right?
Yes.
Yep.
Also containing, it's kind of gruesome, a piece of his finger. Or actually, it is his finger.
Yeah, I don't think it's a piece. It's like the whole
like the
finger.
actual
It's the whole finger.
It's kind of weird, but you can go see it if you're into that. It's kind of weird. Anyway.
Right, and so, while the telescope might be rudimentary, the discoveries that he was making with it are remarkable, right? And I think it's incredible that observations of something as simple as, these little dots orbiting around Jupiter have revealed so much to us over time and continue to reveal so much to us today, right?
By the way, those little abbreviations next to the moons there, ORI, it's abbreviated for Orientalis, as in east, and then occidentalis, OCC, west. So this is telling you east and west, and you're thinking, wait a minute, I thought east was to the right and west was to the left on a map. If you're talking about the sky, look up at the sky, face south, look up at the sky. East will be to your left, west will be to your right. So he's actually drawing this, indicating directions in the sky.
Now, it looks like we can get a little bit of proof with these moon orbits, right, orbiting around Jupiter in our telescope view right now. We are 4 minutes past Io reappearing, and
There
you
it
can
is.
just make it coming out over there on the left side of Jupiter.
That's so cool.
Europa is the one near it, but pretty far apart on the right side. Io is that little dot that you see just coming outside of Jupiter right now. So, wow, whoever wrote the script really timed it out. Nice. That was lucky. That is so lucky.
That would be Hunter.
that would be Hunter, but definitely not planned. And so there you go. There is, beginning to see that proof of something orbiting another body. And to us now, that might seem silly and obvious, I think. But back then, all they were seeing was these objects, passing over in the sky, seeming to orbit around us day in and day out. And so it took some evidence like this to, really make it obvious. You can still just make Io out coming around the outside edge. And so you start to really get an idea of how important observing Jupiter and the whole Jovian system has been for a long time, and how important it continues to be, right? It must be important if we're sending a spacecraft just to go and visit Europa itself. And so with these last little tweaks of our telescope view, and we'll give you an update, of course, on where Io is after this next segment, but I wanted to pass it back over to our chat with Cynthia, getting a little bit more in depth on not only her experiences doing the same thing, right, looking at Jupiter through a telescope, but also, really some more detail on the process of getting something to launch and what that work is like. So we will pass it back over to the interview here.
So, have you ever looked at Europa and Jupiter through a telescope? And if so, what was that like?
It's, personally, I mean, I did astrophysics as an undergraduate, and then I found my way to planetary science because I found that, looking at kind of like far off, faint, fuzzy objects through a telescope, I mean, it's just always kind of disappointing, right? I mean, even if like I got the opportunity to see, we're up on Mount Wilson with a student group, and so we're observing through, one of the big 60-inch historic telescope up there. We got to see, the Ring Nebula through it, and you put your eyeball to it, and it's this little tiny circle, right? And on the one hand, it's amazing that there are photons from that far off in space that are coming through and ending their life in your eyeball, allowing you to see it, right? So that's amazing. But in kind of an experiential, like in the moment kind of thing, I always find astronomical or deep space targets a little bit disappointing through a telescope. And that's just my personal bias. But you point a telescope at the moon, even like a pretty, basic backyard level telescope, and oh my God, it's amazing. And so, same thing with Saturn, right? Anyone who's had the experience of seeing Saturn for the first time with their own eyeballs, even through a modest sized telescope. I mean, I had one experience where I was teaching a class in graduate school, and the students had to figure out where Saturn was and then point a telescope at it and actually observe it. And I had one student who looked at it. She got Saturn right in her telescope. She went around and looked at the other end of the telescope, convinced that I'd printed out a picture of Saturn and taped it there. She couldn't believe she was actually seeing it. And so yeah, Saturn, and of course Jupiter. I mean, seeing Jupiter through any kind of telescope you can get on it, and then seeing those satellites just in a row. I always have to look up which one is Europa and, kind of give it some extra love when I look at it. But it's just amazing.
It is such a special moment. Absolutely.
What you've described is exactly what we sometimes have to go through at the observatory, because there's a plethora of things we could point the telescope at, but people love seeing the bright stuff. They love seeing Jupiter and Saturn and anything that is big and bright. The moon. Oh my goodness. We've had people cry seeing the moon
because it's real. It's real.
Yeah.
Like it's just stunning. Oh yeah. No, totally agree.
And hopefully, as this interview is being broadcast, folks online, the weather is clear and folks online can understand that sentiment, right? Seeing it through the telescope tonight and really starting to understand, there is something different about seeing it with your eyes and it feels so much closer to you and you really connect with it in such a new way.
And then knowing that something is going there, right? It kind of gives that extra special sense. Like I remember when Cassini was about to, when it entered orbit around Saturn, and I went out, and again just with a modest kind of backyard telescope, and I looked at Saturn, and I thought, Cassini is there, right? I can't see it. I'm not, the telescope is not big enough to actually see the Cassini spacecraft, but just to know that humans had built something that was actually there, right? That was actually at that world is, oh, it's amazing, right? And so I think every time I look at, the Jupiter system, when I look at Europa from now on, I'm going to be thinking, Europa Clipper's going there, right? It's on its way. And then 2030, once we actually make it to Jupiter orbit, it's just going to be even more special. So I can't wait.
And just so folks know, no, we can't point the 24-inch at a part of the sky to show Europa Clipper. It's big, but it's not that big.
Yeah.
So
Although
I wish
we will actually have an Earth flyby in December of 2026. And so depending on, I don't remember the geometry of it, but I think it will be possible to observe it. It'll just look like a little bright kind of streak of light from some telescopes, depending on, which side of the Earth it's on. So that will be cool. That'll be kind of the last time that, human eyes will get a chance to see Europa Clipper, I think.
maybe we might be able to see that. We'll check into it. So anyway.
Yeah, we will have to. We'll have to. Well, Cynthia, you kind of already answered our next question. It was, has the coolness factor sunk in that yet that you can look up at Jupiter in the night sky and think to yourself, I mean, you mentioned looking at Saturn when Cassini's on its way there, right? Knowing that something man-made is on its way there. But this time you can say something I made is heading there or is orbiting around this body. Is that a different experience from in the past for you?
I would say it has not sunk in yet. I did go out and look at Jupiter, a couple days after Europa Clipper launched, and I was like, something's going there. Something, yeah, my mission is going there. But yeah, no, it didn't seem real. Um, so I think it's gonna take some time.
Did you actually get to see the spacecraft assembled before it was all
Oh yeah.
packaged up and ready to go?
Yeah, because I work at JPL, and so we had a live feed, like a live, camera link from the clean room where the spacecraft was being built. And whenever they were doing something really cool, a lot of us would run over to the viewing gallery. There's a big window that you can look down on the clean room and see the spacecraft, especially when they're doing a lift. So you have this whole, multi-billion-dollar spacecraft. It's dangling from a cable from the ceiling as they're lifting it up and moving it onto a different stand, or they're rotating it. And oh my God, it was so stressful. I think we all, like we're holding our breath. And of course, I mean, the engineers who work in the clean room are amazing. They know their jobs. We know the crane is strong enough, but still, it was always stressful. And then, we watched it get put in its crate, right? They have this big shipping container. So we kind of were there in the viewing gallery as they closed the door. They lowered the shipping container basically down onto the spacecraft, and they, locked it all in. And then a couple days later, when it was driven out from JPL in the middle of the night, actually, because LA traffic, you don't want a multi-billion-dollar spacecraft on the freeways during rush hour. That'd be a really bad idea. So, at midnight, they basically drove it out, and it was a whole convoy of, police cars and support vehicles, and then the spacecraft itself in its shipping container on this giant, flatbed truck with these, wide load trucks that went before and after it to warn you. And so a small group of us crazy people actually went to the gate at JPL because we got the intel and when it was going to drive out. It's kept hush hush, right? Because they don't want anything bad to happen. But we knew. So we were there waving, and as it drove out in the middle of the night, and the drivers thought we were kind of crazy, but we explained to the guards that, we were just there to wave goodbye. And they're like, okay, fine, you can stand there. You'll be out of the way. So we're standing off to the side. But yeah, and then it went off on its journey from here at JPL to Florida. And then once it was there, it was kind of had its final assembly in a SpaceX facility at the Cape, and was put into its payload fairing. And so that's the last time that, human eyes would ever see the spacecraft, right? So that was another really special moment, watching it, the sides of the fairing be closed on top of it. And we're like, there it is. And then at the launch, I was fortunate enough to get to be, out at Kennedy for the launch in person. And so the day before the launch, a couple of us drove off because we have, fortunate enough to have a badge to get on the NASA base there. And so we actually drove over and got as close as we could to the spacecraft, and we saw it, up on its rocket, and there's the payload fairing on top with the Europa Clipper logo on it. And we were like, it's there, like it's really there. It's really on that rocket. So yeah, it's just amazing.
I think everybody imagines, when they imagine a mission like this, the scientists like you, Cynthia, that are working away, planning how the spacecraft is going to work and everything. But sometimes you can forget all of these other little details that go into it, right? It really takes a village. These drivers that are delivering it all the way to the East Coast from the West Coast, right? And all of these little pieces that have to come together to make a mission like this possible.
It's been amazing. And, to be very clear, they don't let me touch the spacecraft, right? I mean, they keep me far away. I did get the chance to go into the clean room once, where you get to wear, the full on, like the bunny suit and the mask and the hat and the gloves and the booties, because we want to keep the spacecraft super, super clean. And I did get to go in there we were filming something. And so I volunteered, of course. So yeah, I'd love to go do that. And so, we had a minder who was one of the engineers who was basically assigned, I think, to keep an eye on us, kind of like stupid people, to make sure we didn't blunder too close to the spacecraft. And so they were very clear. Okay, you can stand here, now don't move, right? Don't walk any closer, don't move, don't touch anything, right? But I did get to breathe the same air as the spacecraft, and that was cool. That was really cool. I did not lick it, I did not touch it. I was a little bit tempted, but I didn't.
The geologist says, I did not lick it. Sometimes geologists really do lick rocks. I don't recommend doing that.
Yeah.
But
it's a legitimate way to do it.
Yeah, it's okay. Don't go out and lick a rock unless you know what you're doing. So, right. All right.
And definitely don't lick any spacecraft.
Don't lick the spacecraft.
Don't lick a spacecraft.
Not that one.
I resisted temptation.
Well, we ended on a little bit of a funny note there at the end of the interview, right? Talking about licking rocks and spaceships. But, I mean, so much insight there on, something I never even thought about is the process of transporting something like this Europa Clipper from where it's being made in California all the way across the entire country to be able to launch it, right?
Right.
So much work that goes into it.
So many thanks to Cynthia Phillips, Dr. Cynthia Phillips from the Jet Propulsion Lab in California, and to Sarah Marcotte at the Jet Propulsion Lab, and to the rest of the Europa Clipper team and everybody out there. I think they're going to be busy for the next 5.5 years.
It is a while until it makes it there. I think they've got a lot more work to do. So it's something that we did continue to talk to Cynthia for a little longer and had some more conversation with her. And doesn't sound like it's a 6-year vacation. I don't think. No, it's a lot more planning. They had to do as much planning as they could to get it launched, and now they got to keep making sure that they're really ready for those really, really essential moments, right? When you're orbiting around Europa and collecting that data. And one thing that we covered a little bit in some of our further conversations with her is really this question of why Europa. We keep talking about the price of a mission like this, how expensive it is, and so it's a really hard decision to decide, hey, we're going to build a spacecraft and we're going to send it there. You're committing a couple decades of work, over $1 billion usually. They do these really huge decadal surveys to really get an idea of what they might be interested in looking at in these big years. So, answer that question a little bit for us. Like, why Europa? What's so exciting about it? What makes us want to visit, right?
We are expanding our idea of where the possibilities of life might be in our solar system. It isn't just places like Earth. There's only one place like Earth, and that's Earth. It's not just Mars, which is that kind of reminds us of Earth a little bit. We have to think about other places that could be habitable for life. And that's the question we want to answer with Europa Clipper.
Right.
Is Europa habitable? Not does it have life? We can't answer that yet. Could it host life? That icy crust, that salty, we think salty ocean under the crust. could there be something living maybe in that ocean?
Right.
It's tantalizing to think about.
And I think that this is a question that people maybe don't expect to hear out of astronomers and scientists, is like the driving purpose for a mission being finding life, literally aliens, because that has so much been caught up in the idea of science fiction and it's so many different ideas that we want to have for what aliens will be, but we really don't know, right? And this is how you find out. And these are the important kind of work that it takes to really get there.
Yeah. One of my favorite science fiction authors, Arthur C. Clarke, writing 2010, which is a sequel to 2001: A Space Odyssey. And so it talks about that Europa plays a part in that book and the movie, which was based on the book. So.
Well, I think that something that has really stood out to me ever since we talked to Cynthia, and what I've been telling people when I've been telling people about that interview since then is, sure, we have a lot of work that we've put towards trying to find evidence of life on Mars, trying to see these things closer to home, right? It's easier to visit. But there's a chance that life could have traveled from Earth to Mars, right? And getting further out there, getting to Europa, if we find life there, then that really helps us see a second foundation of life, right? It forming in two different places just in our little solar system. And if it's happening twice here, there's got to be a pretty good chance that it's happening in a lot of these other places too, right?
Yeah, right now we have, how many examples of a world with life do we have?
Yeah,
One.
And we're going to need some more examples to really start expanding our ideas of what life can be.
Yeah, if we can find one other one in our own solar system, that would be just, there'd be no other science topper of a story, that's for sure.
Now, one thing that is really exciting about the Europa Clipper is, it is going to visit, we mentioned this earlier, one of these maybe less thought of places in the solar system, right? What everybody thinks of first is these big planets like Jupiter. Why aren't we sending another mission to Jupiter, right? And I think something that we've really found out recently is that, there's such a huge diversity of worlds out there, and we don't need to be restricted by just these big planets that we think of. And so just this year, the Other Worlds exhibit opened here at the Planetarium and really goes into depth on really the breadth of different kinds of worlds there are out there. And I think Europa is such a great example. We don't have a planet that matches what Europa looks like, right? And so it's gonna take continued research, and it goes beyond just these moons in our solar system. It goes all the way to exoplanets, right? These planets orbiting around other star systems, right?
And you can come to the Adler Planetarium over winter break or some other time if you want to visit our almost brand new, opened earlier this year, exhibit called Other Worlds. And it talks about not only planets in our own solar system, places in our own solar system, but different types of worlds that are out there, and even getting into exoplanets, and so planets around other stars. So it's really cool. And
I think it's been a really great, exciting addition to our galleries here. And so I definitely recommend checking it out. It's a big shift from the solar system gallery of the past.
And when you talk about our newest exhibit, which is Other Worlds, our exhibit that has been on display the longest, which is The Universe in Your Hands. And it looks like Evan Boxer Cook visited last winter break and had an amazing time. Thank you, Evan. Spending most of your time downstairs. Any thoughts on the astrolabe collection? Evan, my friend, astrolabes are incredible. If you're not familiar with an astrolabe is essentially, if you could call it a medieval computer, but it's an instrument that can be used for navigation, for surveying, for doing all sorts of things. It's flat. And so imagine a flat disc, but usable on both sides, and you sight a star on one side, and then you turn it over, and there's essentially a movable star map, star pointers on the other side, and you line up where that star is, and you can among other things, use those instruments to navigate.
Right.
Well, we have
Sorry I didn't have a picture ready for that. I was ready
Yeah,
to go
that's
for that one.
okay.
That was an unexpected discussion. But, at an astronomy-focused museum, collections is kind of a tricky thing to handle, right? I mean, you can't really bring space down to us, except for the rare occasion that an astronaut does, or space does itself with a meteorite, right?
Yep.
And so a lot of the things that we have are the tools that have been used for astronomical research for centuries.
And astronomical research, astronomical observations from astrolabes to Galileo's
yeah, mock Galileo
Galileo's
telescopes.
telescope.
Or real old telescopes from the
To
1600s.
Europa Clipper to anything in between. The Voyagers, Voyager 1, who we showed the time-lapse imagery earlier. It's incredible to think people, what comes down to it with all of these is people.
Absolutely.
People made these things. People used them or are going to use them. People needed them for a reason, and so they built them, and they are absolutely incredible. If you're not familiar with our astrolabes, definitely check them out. And I love I've always loved the way we've had them on display, which is you can see both sides.
Both sides, yep.
And yeah, we've got some really unique ones too.
Sorry, I wasn't laughing at the astrolabes. I was laughing at this comment. Wanted to wish a happy birthday to Janelle because their favorite planet is Jupiter. We can certainly do that for you.
Absolutely.
And as a birthday present to Janelle, I think we should get an update on how Jupiter's doing so far.
Yeah, check it out.
Notice the movement that we've had in those moons there, right? I was just peeking around before, and now we're actually seeing some separation between Io and
Do you want me
Jupiter,
to do
right?
an earlier picture just so people can see?
You're welcome if you want to. Yeah, you're welcome to compare.
There we go. Hang on.
And while Michelle does that, there's another question, is we already talked about the red spot. Is it true it's a storm? Very good question. We did talk about this a little earlier, but we don't mind going back over that again. So Michelle made the distinction that it is a little different than a storm. You said it was a high pressure system. Is that right, Michelle?
It is a high pressure system.
Yeah, and so what you're really seeing there, why it's looking a different color, all of these things, is it really all comes down to lots of movement in the cloud structures that are in the atmosphere of Jupiter, right? So what we're seeing when we look at Jupiter is all of these different cloud structures, and you see Michelle working away back there on the computer, and you can see the updates here on the stream. She's looking at different pictures that we've taken throughout the night to compare those moon placements, but Io was a great, real obvious answer to that question, fortunately. And so yes, this red spot is just a part of all of those different cloud structures. And actually, you can see on the surface, or sorry, apologies, communication there. Not a surface, it's just gas up there that we're seeing. But you can see some of these darker stripes across it and lighter areas. What that really all comes down to is different gas moving in different ways, sort of like weather patterns on Jupiter. That's the closest comparison to what we have here on Earth. And now, I know it's tough to see. Michelle's gonna point it out with the mouse here. That is the great red spot there. More than anything, I notice a break in the dark orange belt that's across there, which I think is technically the southern equatorial belt. I think we're seeing this flipped upside down. And so you can almost just make it out. Though I will say, it's not as great in red as maybe its name kind of implies.
It is, as I like to call it, the great salmon spot right now.
Yeah, sometimes faint salmon spot, if I'm gonna be honest.
Yeah.
It's tough to catch. But you can definitely see it making an impact on the equatorial belt there for sure.
Yeah.
Well, that is most of the stuff that we have for tonight. Of course, we always end the show with observations when we can, because we got to take advantage of the clear skies that we do get, though the clearness of the skies seems to be diminishing a little bit at the moment.
If you're wondering why the image keeps getting brighter and dimmer,
There's a little bouncy.
It's bouncy because of the moving air. It's kind of windy right now. And also there's, we think there's a little bit of cloudiness out there.
Yeah,
as
just
well.
some spotty ones
just
coming
a tiny,
in, but
just a tiny bit.
not so bad. A good view.
It's looking pretty good.
Got a good view of Io peeking out around the back, and again, of course, it was wonderful to talk with Cynthia Phillips from the Jet Propulsion Laboratory.
And I think the sky gave us just a great view of Jupiter tonight. You actually can help the Adler Planetarium. It's Giving Tuesday tomorrow, if it is. If I
That is
remember
true,
correctly.
yes. The sky was feeling very generous. And if you enjoy the content that we produce, if you enjoy, you know, what we do for the community and spreading astronomy knowledge and goodness, Jennifer will put a link in the chat. Tomorrow's Giving Tuesday, so if you would like to donate to the Adler, it goes towards programming like this.
Yep.
And all of the other wonderful stuff that we do here at the museum. So we greatly appreciate that. If you're joining locally from here in the city, come out and visit us sometime. You can also come and look through this telescope on clear Wednesday evenings. We mentioned that earlier. This Wednesday we won't be open, but keep an eye out for that, especially as the weather starts to get better moving into spring. It'll be more common. You can keep up with that on our Facebook group, Scopes with the Adler. And subscribe down below if you're checking us out from a little further away and would like to keep up with our digital presence as well.
Definitely, and one of our telescopes is out where you are with Scopes in the City. Definitely come and hang out with us. We love to meet you in person. So if you are ever here and you say, "Hey, are you Hunter? I saw you on YouTube." That actually has happened to us.
It definitely has. It definitely has. Within a couple days of a show is when it happens most
Yep.
often, for sure. So
Yep,
I'm glad these
definitely.
calls to action work sometimes.
Yes, definitely say hi. We would love to meet you in person. That would be great.
And if you were outside observing with us tonight, we've got some links to our social media there. We'd love to see observation photos from folks. So if you've got a picture of Jupiter in your sky tonight, tag us, use the hashtag #lookup, and we would love to see what you were looking at with us this evening. Other than that, do you have anything else for the folks at home tonight?
Hey, stay warm, everybody, and please definitely check out Jupiter in the night sky.
Yes, if you end tonight with anything, I hope that it is going outside and checking it out, but we will also end the show with a little live view through the telescope. So thanks so much for joining tonight, everybody, and we will see you on the next episode of Sky Observers Hangout. Cold out here.
It's definitely
My face is
cold.
starting to freeze.
Yep.
Thanks, everybody.
Thank you so much.
Bye.
Good night.